In this video, I'm going to go through 6 examples of quadratics, and what we're going to do is for each of the equation that we're given, we're going to find the discriminant, state what the number is, and then based on that number tell what number of solutions we could have, meaning x-intercepts. They're also called roots or zeros. And then also what we're going to do is decide if your equation can be solved by factoring. And so real quick, I just want to review what we learned in the previous video, that depending on your discriminant, if it's positive, you'll get 2 solutions. If the discriminant is 0, you'll get 1 solution. And if your discriminant is negative and we put that number into a radical, what's going to happen is you're going to get an undefined answer, and so what it's going to be is that there's no real solutions, meaning your parabola just happens to not touch the x-axis. And then the discriminant, if you get a perfect square, then your expression can be factored. And so if you don't have this kind of highlighted in your notebook, or if you don't have it written down, this would be a good kind of cheat sheet to have off to the side. So a positive discriminant, 2 solutions, 0 is 1 solution, a negative discriminant, so those 3 cases would be no real solutions. And if we get a perfect square, a positive perfect square, then we could have factored. So I'm going to go through 6 examples here, and we'll start with this one. X squared plus 5x equal to 14. Now what you need to have is your equation set equal to 0. And so first I need to rearrange this and subtract the 14 to the other side. So we have x squared plus 5x minus 14 set equal to 0. And so my a here in this example, my a is going to be 1 because I have 1x squared. B is equal to the number in front of your linear term, so 5, so that coefficient. And the constant term, the number with no letter, is negative 14. And the discriminant is, I'm going to write this at the top, b squared minus 4 times a times c. And you want to make sure you multiply those 3 before you subtract. And make sure if you have a negative that you use parentheses before you square, because a negative times a negative should get you a positive. So this front number should always be positive. So my b squared would be 5 times 5. And then I'm going to subtract 4 times 1, which is my a, times c, which is negative 14. So this is going to be 25 minus, now I'm going to grab my calculator. All right, 4 times 1 times negative 14 is negative 56. And so since I'm subtracting a negative, I'm going to add. So 25 plus 56 is going to be 81. This is a positive number. And so I'm going to have 2 solutions. Since 81 is a perfect square, yes, we could have factored. And then my graph. Roughly my graph could be, and actually I'm gonna actually solve this one. 2 numbers that multiply to make negative 14 and add to make 5. I'm thinking a 7 and a 2. 7 and a 2 will multiply to make 14, and if I want a positive 5, I want a positive 7 and a negative 2. And so now what I'm going to do is actually solve. My solution here would be negative 7. My solution here would be 2. So at negative 7 and at a 2, roughly, this would be our picture. Okay, here's another one. 2x squared minus 4x equals negative 3. Remember, you have to have set equal to 0, so I'm going to rearrange this. 2x squared minus 4x plus 3 if I add that 3 to the other side. So here my a is 2, b is negative 4, c is 3. So I'm going to take negative 4 and square it. Negative 4 times negative 4 is 16. I'm going to subtract 4 times my a of 2 times my c of 3. And then 4 times 2 times 3 is 24. And 16 minus 24 is negative 8. And a negative number is going to have no real solutions. Negative 8 is not a perfect square, so it would not be able to be factored. And a picture of a graph that has no real solutions would be a picture of a graph that does not touch the x-axis. So the graph would be above the x-axis and it will not cross it. All right, here's number 11. So I do have set equal to 0 here. So my a is negative 3, b is 5, and c is equal to 1. So my b squared would be 5 squared, and then subtract the number 4 times a of -3 times c of 1. So this will be 25 minus a negative, and 4 times 3 is going to be -12. So minus a negative I'm going to add, and I get 37 for that number. It is a positive, so I will have 2 real solutions. 37 is not a perfect square, so no, we could not factor this. And so we just want to have a parabola that will have 2 real solutions. Now I do notice that my front term is a negative, and I know this is going to open downwards because that front term is negative. And if you didn't know that, that's okay. But it should have 2 real x-intercepts. I don't know where those would be yet, but I just know that I'd have 2. All right, we have 3 more examples for this video. In this example here, what I'm going to start with is, I notice there's a GCF here. So I'd have 1x squared minus 2x plus 1. And my a here is 1 because I divided out that 3 that they had in common. B is -2 and c is 1. And if I do my discriminant here, b squared would be -2 squared minus 4 times a, which is 1, times c, which is 1. I get 4 because -2 times -2 is 4 minus 4, and I get the number 0. Now let's say you didn't notice there was a GCF. Would that have changed our answer? I'm going to tell you no, it won't have changed your answer. So let me grab another color here. B squared would be, if you didn't take the GCF out, -6 squared minus 4 times a, which is 3, times c, which is 3. This is going to be 36 minus 12 times 3. 4 times 3 is 12, times 3 is 36. Would you get the same answer? Yes, you would. Even if you didn't notice that GCF was there, you're still going to get 0 for your discriminant. And if you get the number 0, that means you would have 1 real solution. The square root of 0, I guess technically 0 is a perfect square, so could you have factored? Yes, you could have, and I'm actually going to show you. Let's factor this. We took the 3 out. We had x squared minus 2x plus 1. What numbers multiply to make 1 and add to make -2? -1 times -1 multiplies to be +1, and -1 minus -1 makes -2. So notice how that factor is the same factor. This is why you will have 1 intercept. And notice that that factor is the same. So this is what happens when that factor shows up twice. It will touch that point and turn around and go right back up because your parabola is only going to have 1 intercept, so it has to be your max or your min on the graph. And since I have a lead term that's positive, it's going to open upwards. All right, here are the last 2. I noticed here we have a GCF of 2, but even if you didn't notice the GCF of 2, you will get the same answer for your discriminant. 3x squared minus an x plus 2. Okay, so my a here is 3, b is -1, c is +2. So b squared, -1 squared minus the number 4 times a of 3 times c of 2. So b1 minus, oh, this is going to be a big number, 4 times 3 times 2, 24, you're going to get a -23. So no real solutions. This is not a perfect square, so no, we could not factor. And again, your parabola is just not going to touch the x-axis. So positive square term means that it's not going to touch the x-axis, and it should open up here, not touching the x-axis because no real solutions. I didn't quite make that as clear. All right, very last one here. Again, you have to have set equal to 0 first. So an x squared minus 3x. If I add that 2 over to this side, then I'll have set equal to 0. So my a here is 1x squared, b is -3, and c is 2. So my b squared is -3 times -3, oops, not equals, minus 4 times a of 1 times c of 2. So this will be 9 minus 8, and we're going to get 1. 1 is a positive number, and so it will have 2 real solutions. 1 is also a perfect square, so yes, we could have factored. I'm actually going to see if I can factor that. Two numbers that multiply to make positive 2, add to make negative 3. Has to be a 2 and a 1. And if both of these are negative, negative 2 minus 1 more, we will get a solution when we add of negative 3 here, but our zeros would be x plus, minus 2 equals 0. Add your 2 over, you get 2. X minus 1, set that equal to 0, you get a solution of 1. So 1 and 2. There's your parabola. So it's going to cross your x-axis at those 2 points, at the number 2 and at the number 1.